This lesson is negative exponents. The question is what happens when the exponent is negative. When you have a negative exponent, you can move the number from the numerator to the denominator or from the denominator up to the numerator. The thing that you have to remember is when you move it back and forth, you're going to change the sign. So if it's positive, you're going to change it into a negative, and if it's a negative exponent, you're going to change it into a positive one. These first 5 examples are just showing how to rewrite these expressions with positive or negative exponents, how to go back and forth between the two. The first example is 5 to the negative second power. If I think of this as a fraction, I can just put it over 1. And if I want to move my 5 to the negative second power down to the denominator, I'm going to write my negative second power as a positive second power because I'm changing the sign of my exponent. Because I don't have anything in the numerator right now, I'm going to use 1 as a placeholder. So 5 to the negative second power could be written as 1 over 5 to the positive second. Our next example is 1 over 7 to the second power. This time, if I want to take my 7 to the second power and move it up to the numerator, I'm going to change the sign of my exponent. So 7 is going to stay the same, and instead of positive second, my exponent is going to be negative second. The next example is y to the negative fifth power. Again, this one's not a fraction, so let's make it into a fraction by putting it over 1. If I take my y to the negative fifth power and move it down to the denominator, my negative fifth power is going to turn into a positive fifth power. And again, I'm going to put a 1 in the numerator as a placeholder. The fourth example, if I take x to the 8th power and I move it up to the numerator, my exponent of positive 8 is going to turn into a negative 8. So I'm going to rewrite this expression as x to the negative 8th power. Finally, in my last example, if I start out with a negative power in the denominator, such as 6 to the negative 4th power, and I move it up to the numerator, I'm simply going to change my exponent from negative 4 to positive 4. The next thing we're going to do is simplify expressions with negative exponents. Most of the time when you have an expression, you're going to be asked to rewrite the expression using all positive exponents. They don't really ever want negative exponents in the answer. So here's how we do that. First thing is, I would take your expression and put it over 1 so that you can think of it as a fraction. And then anything that is positive is just going to stay where it is, and anything that is negative, you're going to move to a new location. So for the first one, x to the 5th power is already positive, so we're going to keep that on the top. But I don't want y to the negative 3rd. I want that to be a positive 3, so I have to take that and move it down to the bottom. So the final answer is going to be x to the 5th power over y to the 3rd power. In the next example, again, I'm going to write it over 1 so that I can think of it as a fraction. And anything that has a negative exponent is going to get moved down to the denominator. So that 4 to the negative 9th power is going to get moved to the denominator, and our negative 9 is going to become positive 9. 8 to the 6th power already has a positive exponent, so that can just stay on the top. The next example, a to the negative 5th times b to the negative 2nd. I'm going to put it over 1. Now this time, both of the variables have negative exponents, so I'm going to have to move both of them down to the denominator. If I were to move both of those terms down to the denominator, I'm going to have a to the positive 5th and then b to the positive 2nd. And since I have nothing on top, we're going to write a 1 in the numerator as a placeholder. Our last example has 3 variables, so we'll just do them one at a time. First thing is I'm going to write it over 1 to think of it as a fraction. X to the negative 7 cannot stay like that, so we're going to move it down to the denominator, and we're going to change our negative 7 into a positive 7. Y to the 4th power is already positive, so that can stay on top. And z to the negative 11th power has to get moved into the denominator and given a positive exponent. In this next set of problems, we're going to find the value of each expression. So the first step would be to write it exponentially, and then after that, we're going to actually find the value of it. If I have 3 to the negative 3rd power, the first thing I want to do is I want to rewrite that with my exponent in the denominator as a positive 3. So 3 to the negative 3rd power would be written as 1 over 3 to the positive 3rd. So that's how we would write it exponentially. But now we're actually going to figure out what 3 to the third power is. 3 times 3 is 9, times 3 more is 27. So the value would be 1 over 27. The next example is 11 to the negative second power. Again, I want to rewrite this one with a positive exponent. So instead of 11 to the negative second, I'm going to write it as 1 over 11 to the positive second. And when I figure out 11 to the second power, that's 121. So the answer is 1 over 121. The third example looks very much like the second one, except this time we have negative 11. And since that negative sign is in parentheses, when we write this one, we're going to write it as 1 over negative 11 to the second power. Negative 11 times negative 11 is positive 121. So we're going to end up with the same answer as we did in our last example. But because that negative sign is in parentheses with the 11, that means it sticks with our 11, and two negatives give us a positive answer. In the bottom row, the first example starts with 2 to the negative 10th divided by 2 to the negative 4th. For this problem, we're going to keep the base of 2, and we're going to subtract our exponents. When I do negative 10 minus negative 4, that double negative really changes it into plus positive. So negative 10 plus positive 4 equals negative 6. So our expression is rewritten as 2 to the negative 6th power. We're going to write that with a positive exponent by moving it into the denominator and rewriting it as 1 over 2 to the positive 6th. When I multiply 2 to the 6th power, I get 64. So our answer is going to be 1 over 64. In our next example, we have a multiplication problem. So this time we're going to keep our base of 4. We're going to add our exponents together, and 3 plus negative 5 is negative 2. I'm not going to keep it like that. I'm going to rewrite it with a positive exponent. So I'm going to write this problem as 1 over 4 to the positive second power. 4 squared is 16, so our final answer would be 1 over 16. Now this last example looks very much like the one above it. However, we don't have parentheses around our negative 11. So the way we're going to read this last example is the opposite of 11 to the negative second power. So this negative sign in the front, or this opposite sign as we're going to think of it, is just going to be written in front of our fraction. So the opposite of, if I have 11 to the negative second, I'm going to write that as 1 over 11 to the positive second, moving it down to the denominator. 1 over 11 to the second is 121. And we want the opposite of that, so we'll simply bring our negative sign over.